co-founder and CEO Jensen Huang, who has no doubt AI is about to change everything.
It does quadrillions of calculations a second. It's just insane numbers.
Is it doing things now that surprise you?
We're hoping that it does things that surprise us. That's the whole point.
NVIDIA's new AI chip might be a real danger, setting off alarms everywhere. This technology isn't just better. It's changing the game in ways we never thought possible. As NVIDIA's worth shoots up,
the rate at which we're advancing computing is insane. Over the course of the last 8 years, we've increased computation by 1,000 times.
competing with giants like Microsoft and Apple, their Blackwell architecture brings in a whole new level of AI power. What does all this mean for us? Join us. Let's uncover the urgent risks behind NVIDIA's latest breakthrough.
NVIDIA was the belle of the ball. Today's gain was yet another record high.
The silent revolution, NVIDIA's AI leap. People are now debating what this could mean for the future of artificial intelligence. Why is NVIDIA's new AI chip such a big deal? Let's explore how this could be a game changer and even a potential threat to humanity. NVIDIA started out by making graphics better for video games. Based in California, it has grown fast and is now one of the few companies worth over $2 trillion, like Microsoft, Apple, and Alphabet, Google's parent company. NVIDIA's value jumped from $1 trillion to $2 trillion in just 8 months because of the high demand for its advanced technology, which is driving the boom in AI. But this wasn't the end of the story. NVIDIA's success with the Hopper products significantly increased its market value. Not stopping there, NVIDIA introduced the Blackwell architecture, named after David Blackwell, a famous American mathematician. His work in game theory, probability, information theory, and statistics is key to modern AI models and training algorithms. At a recent conference, NVIDIA's CEO, Jensen Huang, talked about the Blackwell chip. He explained that it's more than just a regular processor. It's a whole platform that goes beyond traditional GPU standards. Blackwell has a unique design, combining 2 chips in one unit, which makes it very fast and efficient. It can communicate at a speed of 10 terabytes per second and works perfectly without any memory or cache problems. Even though there were doubts at first, NVIDIA has made big strides with this advanced chip. Blackwell is designed to work seamlessly with NVIDIA's Hopper, making upgrades easy. A prototype board shows off its power by pairing 2 Blackwell chips and 4 dies with a Grace CPU connected through very fast links, boosting computing performance. But this isn't the only impressive part. NVIDIA has called this period generative AI to highlight a big change in computing technology. The new NVIDIA processor, designed specifically for this era, includes the FP4 format for content token generation. This processor is a key part of the NVIDIA Blackwell AI supercomputer, offering 5 times the capacity of the previous model, Hopper. NVIDIA is not stopping here and is already planning an even bigger and more powerful GPU that will surpass the current model. But that's not all. With these advancements, NVIDIA is pushing the boundaries of what's possible in computing, making significant strides in performance and efficiency. The improvements in speed, energy savings, and data synchronization are set to change the landscape of technology, paving the way for more advanced and capable AI systems. The DGX series isn't just about more power. It's a big step toward exaflop computing in a compact design. Only a few systems in the world can match this capability, making the DGX stand out in high-performance computing. The secret to this power is NVIDIA's NVLink architecture, which can handle 130 terabytes per second. That's more than the total capacity of the entire internet, showing just how much data this system can manage. But this isn't the most surprising part. The DGX achieves this performance without using costly optical components. This approach cuts costs and reduces power use by up to 20 kilowatts, in setups that typically need about 120 kilowatts. The cooling system is also impressive. It uses a liquid cooling method to keep the system at a steady 25 degrees Celsius, even during heavy use, ensuring it always runs smoothly. Let's dive deeper into NVIDIA's technology and its impact on artificial intelligence, AI. At the heart of NVIDIA's setup is the GPU. These GPUs are amazing feats of engineering, built from over 600,000 parts, and each weighing around 3,000 pounds, about the same as a large car. They are essential for handling complex tasks, like training advanced AI models that have trillions of parameters. These tasks used to take months and a huge amount of electricity. However, with the new Hopper architecture, NVIDIA reduced the time and resources needed. What used to take months now only takes 90 days with 8,000 GPUs. But here's where it gets even more impressive. The Blackwell architecture does the same job with just 2,000 GPUs and much less power, only 4 megawatts. This shift in efficiency and performance highlights NVIDIA's leadership in the field. NVIDIA is set to make a huge impact in AI computing with what could be their most successful product launch yet. But that's not all. They're stepping into a new realm with NVIDIA Robotics. This move takes them beyond just crunching numbers and running AI on platforms like the DGX. They are now exploring how AI can interact with our world, making machines more than just processors, but active participants in real-life situations. Next, explore how robots are starting to think for themselves. Robots making their own decisions. This new approach could change how robots interact with their surroundings, allowing them to make decisions and act on their own. It's not just a small step in technology. It's a big leap towards making AI a natural part of our daily lives. Imagine a future where AI can interact with the physical world as easily as it handles data. But that's not the end of the story. Behind the scenes, NVIDIA has been working hard to build a strong system for robotics. They are using their powerful AI systems like the DGX to train complex models, and the AGX, a special robotics processor designed to handle fast sensor data efficiently. Connecting the digital and physical worlds, NVIDIA's Omniverse is a top-notch virtual simulation platform hosted on the Azure cloud. This platform allows for a fully automated warehouse where humans and machines, like forklifts, work together smoothly. It acts as an advanced coordinator, ensuring safety by monitoring the movements of both people and machines in the warehouse. The system works without any delays, allowing real-time interactions in this smart warehouse, where each robot works independently, greatly increasing productivity. But the best part is still to come. Project Grace is an ambitious plan to advance humanoid robots. It's not just a small step forward, it's a huge leap in what robots can do. This project sets a new standard for how robots understand and act on different types of instructions and past experiences. At the core of this project is Isaac Lab, a state-of-the-art robot training tool created by NVIDIA. This software, powered by Omniverse Isaac Sim, provides a virtual space where humanoid robots can practice their skills through simulations, getting ready for real-life tasks. But this isn't the most impressive part. Project Grace also enables robots to understand and follow natural language commands, making them much more functional and interactive with humans. These robots can do more than simple actions like giving high fives. They can also perform more complex tasks, showing a level of intelligence and flexibility that seemed impossible before. The secret behind these improvements is NVIDIA's new Jetson Orin robotics chips, designed specifically to boost humanoid robot performance. As humanoid robotics technology advances, Project Grace stands out as a key player, leading a new era in AI-driven robotics. NVIDIA's commitment to creating top-notch software and cutting-edge technology lays the groundwork for a future where robots become an essential part of our daily lives, transforming industries and changing how we interact with technology. NVIDIA's journey to becoming a tech giant shows its ongoing role in pushing the boundaries of robotics and artificial intelligence. But this isn't the end of the story. Looking back at the 1990s, we remember a time of basic TV screens, slow dial-up internet, and simple beige computers. Back then, early personal computers could only show text and basic images, which was enough for most people. However, those in graphics-heavy fields like animation or engineering needed more advanced tools. This contrast with today's world highlights the dramatic shift from simple tools to sophisticated robotic systems that are set to revolutionize how we interact with machines. In the early 1990s, video game consoles were the go-to choice for gamers who wanted great graphics. But 3 engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, saw that personal computers were missing something. They came up with the idea of a special chip just for handling graphics, which could change how computers dealt with visual information. This is how NVIDIA's story started. These three engineers often met at a local Denny's, drinking lots of coffee while brainstorming. They talked about how central processing units were only designed to handle one task at a time. This made them struggle with the heavy calculations needed for 3D graphics in video games. Their talks led to a big idea, a chip made for parallel processing. Unlike the CPU, this new chip could handle many tasks at once, making it perfect for complex graphics, especially in 3D games. This idea led to the creation of the Graphics Processing Unit, GPU, a chip that would work alongside the CPU, taking care of graphic-heavy tasks. But this wasn't the end of their challenges. NVIDIA's focus was to improve gaming experiences on personal computers, seeing this as a growing market. In 1993, working out of a small condo in Fremont, California, NVIDIA began its journey. The name NVIDIA combined NV for next version, and NVIDIA, the Latin word for envy. They chose green for their logo to symbolize the envy they wanted to create with their top-notch technology. Jensen Huang, one of the founders, had a strong background. He had been the director of coreware at LSI Logic and a microprocessor designer at AMD. His experience in the tech industry provided a solid foundation for NVIDIA, pushing it towards innovation and new heights in computing technology. Now let's dive into NVIDIA's early days and its rise to fame, from $200 to millions. NVIDIA's early gambles. NVIDIA's strategic approach made personal computers more powerful and flexible, especially for graphic-heavy tasks that were becoming more important. The introduction of the GPU was a game-changer, allowing personal computers to handle complex graphics smoothly and efficiently. This didn't just revolutionize gaming, it had a huge impact across many fields, showing how far-reaching NVIDIA's vision and technology could be. NVIDIA's impact reaches many fields needing advanced graphic processing, like video production, scientific research, and professional design. Over time, NVIDIA grew into a major player in technology, known for its innovative skills and boosting computer performance. The founders had a clear vision, especially when they created a specialized graphics chip. This wasn't just about meeting the rising needs of computer users. It also put NVIDIA in a key position to shape the future of computing and support high-level graphic applications. But getting there was no easy task. Jensen Huang, Chris Malachowski, and Curtis Preem, who all had backgrounds at big tech firms like HP, Sun Microsystems, and IBM, founded the company. Even with their experience, starting a new business came with significant challenges. They quickly realized that building a startup was tougher than any engineering problems they had faced before. The three founders faced a critical moment with only $200 to their name. Jensen Huang decided to use this small amount to officially set up NVIDIA, securing a major ownership stake for himself. This move wasn't just about starting a company. It was a big risk in a highly competitive field. The next big challenge was finding financial support. It wasn't enough to have a solid idea. They needed to show a clear vision of success to attract investors. But the worst part was yet to come. At first, they faced a lot of rejections. The tech market was crowded with 89 other companies trying to succeed, so NVIDIA had to stand out. Huang used his connections from LSI Logic to get a meeting with Sequoia Capital, a venture firm that had invested in LSI Logic too. Sequoia was skeptical at first, but eventually saw NVIDIA's potential and invested a substantial $20 million. This funding opened new doors for NVIDIA. They boldly developed their first product, the NV1, in 1995. The NV1 was unique because it used a quad-based image rendering technique, unlike the traditional triangle-based methods. Even though Sega, a major gaming console company, preferred the triangle method, NVIDIA stuck with their quad approach, believing it would ease the CPU's workload and enhance gaming experiences. This decision showed their dedication to innovation and confidence in their unique technology, paving the way for their future successes. During a time when computers weren't as powerful as they are today, NVIDIA made a smart move by using quadrangles to create graphics. This decision helped make rounded objects in video games look smoother and run more efficiently, which was very important back then. The NV1 graphics card had a unique feature. It let gamers play popular Sega Saturn games on their PCs, bringing console gaming to computers. By 1999, NVIDIA had become a publicly traded company with a market value of $600 million. This showed that their early risks and smart choices had paid off. But it wasn't just about making money. It was also about taking chances and coming up with new ideas. NVIDIA's first attempt to combine 3D graphics, video, and audio processing into one chip, the NV1, turned out to be more complicated than useful. It was like an octopus trying to do too many things at once. Most customers wanted simpler chips that focused only on 3D graphics. As a result, the NV1 was expensive and not as attractive compared to its competitors. Plus, the arrival of Microsoft's DirectX, which made it easier for software developers to create graphics, made the NV1 even less appealing. But this wasn't the worst part. This period in NVIDIA's history shows how the company navigated its early years with a mix of technical skill, strategic vision, and determination. The founders had to not only create groundbreaking technology, but also understand the financial world to secure their place in the tech market. They faced many challenges, from getting investments and making bold tech choices to managing partnerships and planning market strategies. Looking back, NVIDIA's journey from a small startup to a tech giant highlights the benefits of facing early problems with a strategic and tough mindset. This time in their history shows how they kept pushing forward despite setbacks, always innovating and adapting in a constantly changing tech world. But the journey wasn't all smooth sailing. Despite the obstacles, NVIDIA's story is a great example of how taking risks and staying committed can lead to big rewards in the tech industry. DirectX chose a simple way to create graphics, mainly using triangles. This made it much easier for developers to work with and include in their applications. On the other hand, NVIDIA initially used an older method that involved using quadrangles for rendering graphics. This choice put their NV1 graphics card at a big disadvantage right from the start. Let's see how NVIDIA faced big challenges and made a comeback. The downfall and resurrection of NVIDIA. As DirectX became more popular, the problems with the NV1 were hard to ignore. The NV1 didn't support OpenGL, a key tool for graphics programming, and struggled with DirectX because of its outdated quadrangle-based rendering method. NVIDIA tried to fix these issues by releasing a software update to make the NV1 compatible with DirectX. But this solution wasn't perfect. It allowed the NV1 to run DirectX applications, but couldn't fully use the hardware's abilities, leading to poor performance. But this wasn't the worst part. The NV1's inefficiency caused big financial problems for NVIDIA. Diamond Multimedia, a major client, found the NV1 so bad that they returned almost all of the 250,000 units they had bought. This was a huge blow to NVIDIA, resulting in financial losses of around $10 million and forcing the company to lay off nearly half of its employees. During this tough time, NVIDIA was also working on another graphics chip for Sega, the NV2, which unfortunately used the same flawed quadrangle design. In a desperate move, NVIDIA's CEO asked Sega's CEO to end their agreement for the NV2 and let NVIDIA keep the payments Sega had already made. Surprisingly, Sega's CEO agreed, giving NVIDIA some much-needed financial relief. Without this help from Sega, NVIDIA's story might have ended there. But this wasn't the only challenge. This difficult period with the NV1 was a crucial learning experience for NVIDIA. It showed them the need to follow market standards and understand what customers want. The experience highlighted the importance of quickly adapting to market changes instead of resisting them. After this setback, NVIDIA focused on developing products that better matched industry trends and consumer needs. The NV1 debacle was a major turning point for NVIDIA, teaching them the value of simplicity and aligning products with market demands. This change in strategy helped NVIDIA recover and eventually become a major player in the PC graphics market. NVIDIA's journey from the brink of collapse to achieving a market valuation of over $1 trillion shows their resilience and ability to adapt and learn from mistakes. Today, NVIDIA is a leading technology giant, demonstrating the power of perseverance and adaptability in overcoming challenges. When NVIDIA faced difficulties in the late 1990s, they didn't just try to recover. They decided to make a big comeback in the PC market with a smart plan. It was 1999, a time when personal computers were becoming common in homes. NVIDIA introduced the GeForce 256 graphics card, a major innovation in the tech world. This card was the first programmable graphics card, starting the era of the GPU, or graphics processing unit. This wasn't just about better graphics. It changed game design, allowing for more detailed and immersive visuals with advanced shading and lighting, greatly improving the gaming experience. But the story doesn't end here. NVIDIA quickly took advantage of this success and went public the same year, positioning themselves well in the competitive market. By 2000, they struck a big deal with Microsoft to create the graphics hardware for the upcoming Xbox console. This was a huge $200 million deal, much better than their previous, less profitable deals with Sega. This partnership was crucial for the Xbox 2001 launch, featuring the NV2A chip designed by NVIDIA, solidifying their place as a major player in the gaming industry. NVIDIA's success didn't stop with gaming consoles. Throughout the 2000s, they became a key hardware supplier for top tech companies like Apple, Dell, and HP, who used NVIDIA's GPUs in their products. Every smart decision and technological innovation NVIDIA made seemed to lead to rapid growth, making them look like they had the golden touch in the tech world. But this wasn't the end of their challenges. NVIDIA's rebound wasn't just about clever ideas. It was also about smart business strategies. One key decision was to operate as a fabless chip company. This means NVIDIA focused on designing the chips while outsourcing the manufacturing to the Taiwan Semiconductor Manufacturing Company. This move was essential as it helped them cut costs and focus on what they did best, designing top-quality chips. This strategic partnership was not a minor detail. It was a crucial part of their plan to reduce expenses and boost innovation and efficiency in their operations. For over 30 years, TSMC has played a key role in NVIDIA's journey, making the advanced chips that power NVIDIA's amazing technologies. They haven't just produced chips, they've been crucial in bringing NVIDIA's big ideas to life, turning complex designs into high-performance products. Jensen Huang often praises TSMC for their important contributions to NVIDIA's success. With TSMC handling the complex manufacturing process, NVIDIA has been able to focus on what they do best, designing and creating cutting-edge technology. This teamwork has allowed NVIDIA to go beyond traditional gaming and graphic designs. Next, witness how NVIDIA's innovations reshape technology. The $2 trillion question. NVIDIA was one of the first to see the potential of GPUs for more than just gaming. They realized that GPUs could handle multiple tasks at once, at incredible speeds. This led to the creation of CUDA in 2006, a software toolkit that made parallel computing easier for developers. Before CUDA, programming GPUs was complicated and not very accessible. CUDA changed the game for programmers by making it easier to use graphics processing units. Before CUDA, using GPUs was mostly about creating visuals, but CUDA opened up new possibilities by supporting common programming languages like C, C++, and Java. This made it easier for more people to use GPUs for different purposes, like medical research and engineering. It wasn't just a tech upgrade, it was a big step forward that showed NVIDIA's innovative vision for the future of technology. The Tokyo Institute of Technology made a significant move by using CUDA-powered GPUs in their supercomputer. This wasn't just about showing off technical skills. It proved how important NVIDIA's GPUs were for advancing computing power. But that wasn't the most impressive part. The real impact of the Tokyo Institute of Technology's decision was how it showcased the practical uses of CUDA. It wasn't just about being competitive in the tech world. It demonstrated how CUDA could solve complex problems in various industries. This move confirmed NVIDIA's leading role in driving technological progress and making advanced computing power more accessible and effective in many fields. By integrating CUDA, industries could tackle difficult computing challenges more easily, paving the way for new innovations. And yet, there was more to come, as CUDA continued to transform the tech landscape. Graphics processing units, or GPUs, are now essential in many areas like cloud computing, machine learning, and video streaming. Big companies like Amazon Web Services, Google Cloud Platform, and Netflix were among the first to use these powerful processors for various tasks. But a major event in 2012 changed the game for NVIDIA, a key player in the GPU market. Alex Krzyzewski, a PhD student from the University of Toronto, introduced AlexNet, a deep learning neural network. He used the power of two NVIDIA GeForce GTX 580 gaming cards to process a huge dataset of 1.2 million images. The results were amazing, cutting the image recognition error rate from 25% to just 15%. Although these numbers might seem small now, they were a huge improvement back then. But this wasn't the only remarkable part. The success of AlexNet changed how people viewed neural networks, which many had doubted before. It paved the way for the advanced AI tools we now use, like ChatGPT, Google Gemini, and Google Lens. The NVIDIA GeForce GTX 580 cards weren't just part of the project, they were crucial. They were specially designed for CUDA technology, which made it possible to run parallel algorithms efficiently. This ability was key for deep learning tasks like those AlexNet handled. The impact of AlexNet sparked a boom in deep learning applications, putting NVIDIA at the heart of this tech evolution. Their investments in CUDA and related software paid off massively. NVIDIA's GPUs became the gold standard for training and deploying AI and large language models, cementing their place as industry leaders. This revolution changed our approach to machine learning and solidified NVIDIA's role in developing AI technology. After ChatGPT was launched in November 2022, the tech world saw a huge rise in the need for NVIDIA's A100 series GPUs. These high-tech processors became very popular as big tech companies rushed to buy them. For example, Microsoft bought 10,000 units, each costing $110,000. Even though they were expensive, NVIDIA sold hundreds of thousands of them, boosting their earnings a lot. By the end of July 2023, NVIDIA's earnings had reached $13.5 billion, a 101% increase from the previous year. On May 25th of that year, the company's stock value jumped to $184 billion in a single day. Shortly after, on May 30th, 2023, NVIDIA joined the ranks of companies with a market value of $1 trillion, and now they are worth over $2 trillion. But that's not the whole story. This rise isn't just about new technology and making more money. It shows how well NVIDIA positioned itself in the market. By aligning their new tech with what the market needed, NVIDIA didn't just follow trends, they led them. Their ability to turn new technology into big financial gains shows they understand the market and what people need. NVIDIA's journey from being a strategic player to becoming a leader in the global tech market highlights the power of combining innovation with smart business moves. And it doesn't end there. This story shows how NVIDIA doesn't just keep up with industry changes, they drive them. They fundamentally changed the tech landscape by setting the pace for the industry. NVIDIA's journey through the competitive tech world has been impressive, marked by smart strategies and amazing innovations. They've shown a great ability to predict market trends and influence the direction of technology. This skill in thinking ahead and creating new advancements has not only kept them relevant, but made them a leader in the global market. Their talent for planning and drive for innovation highlights how a company can go from being just a participant to a leader, setting standards and making the rules. NVIDIA's rise shows how important good market positioning is for reaching the top levels of the global economy. What do you think? Is NVIDIA's new AI chip a true scientific breakthrough, or just a marketing gimmick? Like, comment, and subscribe for more.